Hello, everyone. This is Joris Peels, and this is another episode of 3D Printing News Unpeeled, together with 3dprint.com. So today we've got a couple of stories for you, and we're going to look at, well, the first one is from Koenigsegg. And Koenigsegg is a Swedish producer of hypercars, or very low volume, very exciting, very high priced cars. And we know already that they use 3D printing extensively throughout throughout their design and development, and also parts on the car. And we know that other hypercar manufacturers and also one-off car and supercar manufacturers use 3D printing extensively. And I thought this item of news from the Drive is very interesting, and it's a story by about Koenigsegg using its own resin. So apparently the company mixes its own photopolymer material, or has its own photopolymer material mixed to make components. Christian Koenigsegg says, "We're printing casings for electronic controllers, nozzles for spraying things, underneath the air vents, the flaps, those kind of things are printed at high temperature." He also noted that some upholstered interior components are printed. Koenigsegg didn't really disclose what was in the resin, but he did say it's often custom. We actually sometimes mix our own because we want to mix in anti-static materials and other things. So this is, first off, it's much cheaper for them, right? I mean, that's not. I know probably it's not a very cost motivated company compared to some of the larger car companies. But the whole idea of being able to save a factor of 5 or 10 on the resin, must play a part in this, even if he's not saying it. And normally you wouldn't see this kind of low volume usage result in a really custom material, but it's happened before for Formula One and for lots of other different applications. So I think it's smart, and I think we should really wake up to the fact that if we got companies like BMW or Volkswagen start to 3D print a lot of components, or their supply chain prints a lot of components, we might see a lot of people 3D print a lot of stuff. And we may see a lot of people maybe make their own materials, or maybe not work with larger materials companies and maybe try to get bulk materials made for them. So it's kind of maybe a portent of something for the future, let's say. The next news item is about the Flashforge. It's about their Flashforge Guider 3D printer. Here we see a couple of Flashforge models. And this is a new Pro 3D printer from Flashforge. It's got the Core XY architecture. It's a 300 by 250, 340 millimeter build volume. It's got some internal monitoring capability, double gear extruder, and it can extrude materials around 320 C, so you can make stuff with nylon and other kind of materials. They have, as you can see here, they have a couple of other printers. There's a Guider Plus, which is rapid prototyping, also specialized for kind of filled materials. And then they have kind of like more accurate kind of thing, a Creator 4. So we're really seeing that a company like Flashforge, which was a solid mid-market player, I think 1,000 to 2,000 euros, is now going upmarket, and that's a development that's been going on for a couple of years. XYZ Printing kind of essentially said, we're quitting the ballroom space and we're moving to the professional printers. We've seen other companies do this as well. But now we're seeing essentially people abandoning the middle ground, abandoning kind of the middle, and then all wanting to print, to make pro and kind of more enterprise level printers. And that's also our next news item. That's the next news item, is that BASF, through its Forward AM brand, has actually partnered with Creality. They are creating a line of filaments specifically for Creality. The line of filaments is dubbed the HP Ultra, which I think is difficult. It's very difficult for them to come up with like a more confusing name for materials than HP Ultra anyway. But it's optimized by BASF for the Creality printers. The idea is that Creality then will target enterprise users in China in using the combination of BASF filament and Creality printers. So they're actually going to be coming up with something called the Sermoon D3, which is like an enclosed printer, which is meant to be a higher end offering, and allow you to control multiple printers online as well. So on the whole, this is another development in the same area. We're seeing like that also Creality, which is like one of the most dominant companies in like the $200 printer, is now also wanting to move up. I think For BASF, well, we all know kind of the Chinese printer market is kind of like Chinese only. Essentially, the government really wants wants Chinese companies to buy Chinese printers. A lot of companies have a preference for buying printers from people they understand, they can talk to, and are close to them generally. So typically, the industrial market is definitely kind of almost Chinese only in China at the moment, due to government policy and also just preferences. So I think for BASF, this really makes sense for them to kind of help this player move up in the world, and kind of like Creality is, of course, using the BASF name and things like that. But hey, it might actually get them to do volume in material in China, which, frankly, they're not going to do anything if they don't do anything like something like this. I mean, everybody's going to buy local filament. So to me, for BASF, it's a useful move. For Creality, I can understand that you would want to make more margin and move up in the space, but there's going to be a collision of companies operating in this area. So the next research item is also material extrusion. It's called HotPhil. It's a paper by Ellis Nakonetechai. I'm sorry, it's a very difficult name to pronounce. From the Federal University of Technology in Paraná, Brazil, along with a number of other people. And essentially, they call the paper HotPhil, cooling time constrained raster fill printing algorithm for extrusion, 3D printing. The idea, it's ingenious. There's other things like flow control, the software that allows you to control the flow of your printer and do essentially like custom G code for every part. And there's other people working on different ways of doing this. But what they're doing is they're looking at the adhesion, the interlayer bonding or in-layer adhesion, and they're looking at different types of wait time, if you will, or dwell time, if you will, the law of the nozzle, and you optimizing that as a user by optimizing it for a particular material or even a bigger model. And then they have an algorithm that sets these cooling time limits for different portions in different areas. And this could be a really ingenious thing because, of course, we know that if you do that correctly, this dwell time and this wait time, if you optimize this correctly, then you can get better layer adhesion, get an actual stronger object in the Z direction. So that's very exciting. So generally, this is might be a useful tool for a lot of people, first off. Secondly, especially think about it, like now maybe this would not work for all objects, or it would have to be developed further to be able to plan these optimal tool paths, because that's another thing it does. Is that it also plans the optimal tool path so that it creates this object much quicker as well at the same time. So today, I guess it could work with a slicer to do this, or it could do a software. But imagine you're doing in an industrial setting, you're doing 100 of some objects, or you're doing 1,000 objects in one go, or 1,000 objects for the next month of your life. Then this kind of optimization is going to be much more, as we go into production with material extrusion systems, this will be a much more prevalent kind of technology and things to be thinking about. And the general trend is here that we're seeing a lot more researchers come from AI, from software, from all sorts of directions to try to enliven, make better 3D printing through software. So that's also something that should be encouraged. Now, the other thing, this is another paper, and this is by, another name, Amil Bandyopadhyay, another very difficult name to pronounce, I'm sorry. For me, apologies. And this is a great review paper. It's like a overview paper giving the relevant literature, the relevant practices on alloy design. So I think this is a very, very potentially I wouldn't say world changing, but manufacturing changing kind of development, where a lot of people have been writing for years now about that with DED and with powder bed fusion, you can essentially create alloys on the fly, or design alloys or develop alloys much faster on the fly or in mixes than with traditional technologies. And this means that you could even make alloys for a particular aircraft or a particular aero engine, or at a much lower cost and much quicker to match a certain critical project than was previously possible. Now, this is, I think, an area that's seen quite a bit of research, and what this scientist does at Washington State University is kind of put all the ducks in a row, and line everything really nicely up, from the practices in industry to the relevant research. I thought it was a really relevant paper, really, really handy paper to know for people It's potentially a very exciting area. I mean, imagine like a company like Boeing or a company like, for example, GE would develop a special resin just for one part of its new aero engine. Now, it sounds kind of like that would be crazy, but the costs of doing this are much more achievable now. And if it just gave them a slight edge, that would just give everyone that used that engine just a little bit more mileage or a little bit more better cost picture. So you know, for somebody like the GE additive or GE's aero engine subsidiary, this would be a huge advantage. And it may actually be much more accessible to create alloys for lots of very, very specific purposes. So I think this is a very, very, yeah, very interesting development. And I think I would recommend this to anyone who's working in metal printing at the moment. The other one, the last piece of news, it comes to us from Nature Communications. It's controlling process stability, instability for defect lean metal out of manufacturing. It's by Ming-Li Ku. That's QU of the University of Wisconsin Madison. This is looking at the powder bed fusion metals specifically. One of the problems we have is spatter. In the melt pool, we have melt pool instability. And this leads to kind of droplets coming together, or waves essentially, whatever, waves coming together, and then droplets being formed, and then spatters all over your 3D print. And it might mess up your entire print or your entire build or your part. You might come back after 20 hours, figure out that something has gone horribly wrong, or your object could fail. And what this team of researchers has done is figure out how to mitigate at least the larger spatter in these. This is the good news. I mean, I'm making this the larger spatter, right, to a certain extent. And how they've done this is they've added nanoparticles in the mix. Now, by doing this, they seem to have mitigated at least partially the fluctuations in the melt pool, and it reduces breakup, which causes the and then they also simultaneously have reduced these kind of particle agglomeration, that then these big particles kind of end up spattering all over the place. So that seems like a really elegant solution. I don't know what it would mean to actually implement this. I don't know what it would mean for people making very precise parts if you could just add these materials in it, and to what extent this will change your build or change your part or that kind of thing. But it's nice to see people working on, like, you know, some of the big fundamental problems on what is still a big black box for a lot of people, and that's this powder bed fusion. So, hey, thank you so much for listening to us today again, and I really want to thank you for being there, and yeah, keep up your encouraging words and suggestions, and thanks a lot for